What if I told you time isn't the same for everyone? Right now, the clock on a satellite is ticking a little faster than the one on your phone because gravity affects time. And space, it's not just empty nothingness. It bends, it moves. Gravity isn't really a force at all. It's a story about geometry. Welcome to the mind-bending world of general relativity, where space and time become one and reality gets weird. For over 200 years, Isaac Newton's view of gravity ruled science. He said, "Every object pulls on every other object. The more mass, the more pull. Simple, predictable." But in 1905, a 26-year-old patent clerk named Albert Einstein had a radical thought. What if gravity isn't a force, but something else entirely? He began with one strange idea. If you're falling, you don't feel your weight. That led to something called the equivalence principle, that acceleration and gravity feel identical. This tiny insight, it cracked open the door to an entirely new way of seeing the universe. Einstein realized something profound. Space and time aren't separate. They're part of one connected fabric called spacetime. Massive objects like stars or planets bend this fabric, and what we call gravity is just the result of that bending. Earth orbits the sun not because it's being pulled, but because space-time itself curves around the sun. And Earth follows the straightest path it can, through that curved space. Imagine placing a bowling ball on a trampoline. It creates a dip. Now roll a marble nearby. It spirals inward. That's gravity, not as a force, but as a path shaped by warped space. Here's where things get trippy. Gravity doesn't just bend space, it bends time too. The stronger the gravity, the slower time ticks. Stand near a black hole, and your seconds stretch out longer than someone far away. This is called gravitational time dilation, and it's not just theory. Our phones rely on satellites, each equipped with atomic clocks, but those clocks tick faster than ones on Earth. If we didn't correct for this time difference, your GPS could be off by kilometers. General relativity isn't just abstract, it's guiding your Uber ride. Now, take gravity to the extreme and you get a black hole. A region where space-time curves so much, even light can't escape. Black holes aren't just theoretical. In 2019, we saw one for the first time, an orange ring of light around a dark center. The shadow of a warped reality. But relativity's reach doesn't stop there. Even light bends around massive objects. We call this gravitational lensing, and it lets us see distant galaxies distorted and magnified, like nature's cosmic magnifying glass. Sometimes one galaxy can appear in multiple places in the sky, all thanks to bent space-time. In 2015, a billion years after two black holes collided, a faint ripple reached Earth. Not sound, not light, but a gravitational wave, a ripple in the fabric of space-time itself. We detected it using lasers so precise they can measure a change smaller than a proton. Einstein predicted this back in 1916. We confirmed it 100 years later. General relativity had passed yet another mind-blowing test. General relativity isn't just about black holes and galaxies. It's about how reality works at the deepest level. It tells us that space can stretch, time can slow, and gravity is the result of curves in a fabric we can't touch, but we can feel every second. It redefined how we see the universe and ourselves within it. And the deeper we look, the stranger, more beautiful, and more connected it all becomes. If this journey bent your brain just a little, hit subscribe and let's keep exploring the universe, one mind-blowing idea at a time.